состоялись в МГУ в первой половине 90-х годов, в очень сложное для всех нас время. And Peter Doorn is one of the leaders of History and Computing Association who contributed greatly to development of this field of activities in our country and more widely in all countries of the former Soviet Union. So, Peter, your speech today is part of our old good relations and of our joint projects, joint activities, and just friendship. So, Peter, just start your speech, your presentation.
Okay, thank you very much, Leonid. And yes, it's really wonderful that you invited me. I know that you felt a bit insecure. Wasn't it perhaps too late? And yes, it was a bit, I mean, I had to prepare it at the last days. So that was a little bit of pressure on it. But still, I hope very much that I have something to tell you that I hope you find interesting. I would like to, I made a PowerPoint presentation, so I will share my screen. I suppose that if there are questions that people will post them in the chat, and it's better for me if I can answer them afterwards. And of course, then afterwards also people can ask questions if they want by voice. So I hope that screen sharing will work. Can you see the screen? The slides?
Yes, yes.
Yes, okay. So the talk that I want to give is about fair and open data which is also the theme of the conference, historical data science. I will return in the course of the presentation on how I understand those terms. Let me see. Yes. Now I should say that my personal first encounter with computers is over 40 years ago, in the time of the punch card. And my first experience with a mainframe computer behind a terminal was actually in Mexico, where I did field work. I was trained as a geographer, but in human geography, but also with a lot of attention to research methods and technique, including programming. At the time, it was Fortran 77. That was the preferred language. But I still remember that in Mexico, we collected a lot of data, also in the Ministry of Planning and Finances. And they had just installed a new UNIVAC computer there. And I had never used the terminal. I was there with a colleague student. So it was the first time we used that, but after about 2 weeks, the Mexicans, they came to us and they asked, are you those American programmers that were going to teach us how to work with this machine? So apparently we managed at least to get some data out of it. I work for an institute which is called DANS, or Data Archiving Network Services, which has as a mission to improve science and scholarship by promoting the reuse of research data, including historical data, but for a much wider audience, as you will also see. The building of DANS is in The Hague. Just one slide more about DANS and about this data sharing. This slide gives an impression of the growth of the data archive over the past, 12 years or so, since 2007, 2008. And also concerning broad disciplines. And you see there that archaeology is a very big section of the archive. And there are some more statistics in terms of gigabytes and in terms also of files. In terms of data sets that belong to a certain study, we are now around 150,000 data sets. And in terms of individual data files, one data set consists of more than one file as usual. It is now all approaching 8 million, so more than 7 million data files. Mainly from the Netherlands, but also we have started to provide services to a couple of international customers. But the focus of my talk is on history and computing, or historical data science. The term itself has changed over time, and I want to place it in a historical context. And of course, this doesn't claim to be universal truth. It has also to do with what I regard as things that were especially important or characteristic of a certain decade. You might already say, was it exactly decades? But for the ease of talking, I've divided it into decades, where you could say the 1980s, characterized by the personal computer. And in history and computing, the modeling of historical sources was perhaps an important issue of the time. In the 1990s, we see the arrival of the World Wide Web, where online source publications begin, online collaborations begin, data sharing using repositories begin in history. In the 2000s, important terms are big data and e-science. I will return to this. And the focus will be on the last decade, where linked data, linked open data, fair data, data science are some characteristic terms, and where you could indeed say that we are now in a time that historical data science is occupied with these kind of topics. I will summarize the 1980s and 90s in just one slide. I will pay 5 slides to the 2000s, and the remainder will be to the 2010s. So I already said in the 1980s, perhaps the most characteristic, and I don't want to say that the subject went away. We still have to deal with how to structure historical sources into databases so that we can process them and analyze them. But it was perhaps in the 1980s much more difficult, also because the tools that we had to work with were of course more primitive than the ones we have now. And it was often even a problem. This is the tool, this is my source, and how do I get the data from the source into this tool, into this database? In the 1990s, and that has to do, oh, by the way, this is an example from my personal research, which is on Greek settlement history, which I've been doing for many, many years. I have a beautiful map of ancient Greece there behind me on the wall. But I won't go into the details of that. In the 1990s, it was characteristic that the web came along, and we started to produce and make available data on the web. And it was one of my initiatives to set up a historical data archive in the Netherlands, which started around 1990. But perhaps I should have said that the most characteristic of this epoch was that I met Leonid Barotkin and his colleagues, and that we started collaborations also with Russia. Perhaps they were even more important, I don't know. In the 2000s, we see big data arrive. The term itself is even older, but and perhaps it even comes full-fledged alive a bit later than the 2000s. E-science arrives. There was a book in 2009, so that's already the end of the decade, that was called The Fourth Paradigm, that even claimed that science itself was changing because of data. That data exploration was the new trend, finding patterns in huge quantities of data. There was a whole debate around that. It's not the time now to go into that, but at least that was discussions of the time that were quite influential. We saw the grid, the data grid come up and things like that. In that decade, with 2 colleagues, Onno Boonstra and Leen Breure, I wrote a booklet on that we called Historical Information Science. Already then we had those discussions. Yeah, history and computing is perhaps a bit a vague term. We could perhaps better speak about historical information science, inspired by the e-science ideas. You see that the term e-science dates back to 1999. I will not going to read those definitions for you, but you could look it up. The booklet itself is available freely online at ResearchGate, and at several other locations. By the way, the presentation itself is available as a Google presentation also. So the link is in the chat. If you want to look at that or to download it, you are free to do so. And you can also, of course, then easily follow the links if you are interested. Especially in the humanities and also in history, there was also attention for the question, yeah, is big data also really what we as historians are occupied with? Because at that time, the petabytes of data started to arrive in the 2000s, and mainly from fields such as DNA research or particle physics or astronomy and some other areas, but more in the natural sciences than in the humanities. But it was soon recognized that big data was not just about volume, also the variety and the complexity of data and the veracity, which had to do with the fuzziness, was important. And I always liked very much the definition given by Sayed Chowdhury from Johns Hopkins University, now well known for its famous COVID-19 database that they make available with all kinds of visualization tools, who says that big data definitions should not be just collection-centric, but also be method-centric. And actually, we are dealing with big data if the situation arises that your method doesn't work anymore, the traditional method, and that you have to find new methods in order to be able to process the data we are talking about. Yeah, also very a reference I would like to give you is to the book by Christine Borgman, Big Data, Little Data, No Data, who said that big data begets big attention these days, but little data are equally essential to scholarly inquiry, and you should not forget that. You know, perhaps Leonid will know the name of Kees Mandenmakers, another historian computing person from the Netherlands, who was appointed a number of years ago a professor of big historical data at Erasmus University in Rotterdam. He is going to leave, he's going to retire soon, and I wrote an article for his for the book that we are going to present him. He shouldn't hear it, by the way. But that is exactly on how also the analysis of small data can be very challenging. But I would say that in history, we saw all kinds of collaboratories arrive in different fields. These are just a few examples of such collaboration projects in which we started to combine sources from a variety of sources to make them available through research infrastructures, as they started to be called, in a number of domains. And you see here a selection, but the most important ones in which I personally was involved in that time. But now the looking at the past decade, where we see that data science has come up, and there is a lot of definitions of data science. I'm not going to present those here, but I wanted to focus on a couple of concepts that are important in this context of data science: open science, fair data, and linked open data. And to start with open science, and I don't know in how far that is the case also in Russia, but I would say that in Western Europe, certainly there is a tendency to make science more openly available to everybody, not just to colleagues, but also to the general public. And so you see here a kind of definition of open science: the movement to make scientific research, including publications, data, physical samples, software, and its dissemination accessible to all levels of inquiry of society, both amateur and professional. And it also is an endeavor to become more transparent. By the way, this transparency has also demonstrated that a lot of research and not just in the humanities or the social sciences, but also in the natural sciences, appears to be non-replicable. So if you would carry out the research again, you get different results. And this is regarded as a big problem. And it's one of the reasons why not just the data, but for instance, also the software, the tools with which the data was processed should be available in order to check whether the outcomes of the research are really valid or not. It's not that easy. And in some fields where replication studies have been done, it has been found out that up to 70% of the published results were not replicable. So that's really a critical situation. But on the other hand, people say, yeah, but open science, nothing new. Actually, it is just a continuation of what started in the 17th century when the first academic journals appeared. Sometimes people recognize a couple of different principles of open science. So it is not only about open data, but also about open source, open methods, open peer review, open access, and I cannot read, and open educational resources. Oops. Yeah, the open access movement to make publications freely and openly accessible started already in 2002, and you see that a variety of initiatives has been taken, and the most recent one and important one in Western Europe is that of the European Open Science Cloud, as it is called. I'm going to skip this slide. That was about the taxonomy of all terms related to open science. But the Open Science Cloud is something that might be interesting for you to know a bit more about if you haven't heard of it. It's actually an initiative taken by the European Commission in 2015 with the aim to develop an infrastructure providing its users with services for promoting open science practices. Well, this sounds very general, but you should see that Europe has been funding over the past decade or 2 decades, lots and lots of projects that aimed at these scientific collaborations, making data available, etc., in all kinds of scientific fields. And there were many things many wheels were invented for several times in different areas. And there were also similar problems across fields that people simply didn't see because they were, let us say, encapsulated within their own discipline. And these are the rationale for this EOSC, to try and bring that all together in one kind of a super structure in which the most important services for research are being combined. And this is now going on. I must say that personally, I also have doubts about the whole enterprise because it is so big. I mean, we are talking about multi-million euro projects as individual projects, let alone if you put it all together, and ranging from high performance computing and supercomputers and the facilities for the particle physicists to the databases of the historian. And if that all fits together under one umbrella, so to speak, might also be one bridge too far. But we will see. We are involved in this development. My institute is, I must say, but at the same time, we are a bit aware of the dangers that exist as well of bureaucratization and so on. And now moving over to those FAIR principles that you already saw in the title of my talk. And this concept of FAIR, I don't know how familiar you are with that, but it has received a lot of support in Western Europe again. the basis of that was in Leiden in 2014, where a group of people came together that set that formulated a minimal set of community agreed principles to make data more easily discoverable, accessible, integrated, and reusable, and also citable. So this word FAIR stands for the F for findable, the A for accessible, the I for interoperable, and the R for reusable. And these principles should be true both for people, they should be able to find, access, combine, and reuse data, but also for automated processes, for machines. And that is a very ambitious, it sounds, perhaps that is also the key to the success of FAIR, that it sounds easy and also it sounds attractive, because who would be against that data is findable, accessible, interoperable, and reusable? But the question is, of course, yeah, what does that mean? What does that imply? And to take just one element, the A for accessible, does accessible mean that everything needs to be open always? But this is not the case. The FAIR principles say that the data should be in principle accessible and that there should be a clear license that defines under what conditions the data is accessible. And so for, oh, by the way, the principles were published in Nature Scientific Data. One of my colleagues contributed to this paper. But it was not surprising that many people, it says here everybody, but many people started to love FAIR very quickly. It became a very popular idea. And but of course, the idea was fine, but how to implement it is not so easy. You see that the FAIR principles are subdivided into 15 criteria, even also then on 2 levels. There is no time now to go into any depth, but the links are there so that you can review them yourself. And we started at my institute different ways of trying to assess the fairness of data in practice. How can you establish whether a certain data set is fair or not fair? And we attempted to do that with a kind of a starring system, as you see there in the left-hand corner, but also in a couple of projects. And I personally contributed to another article in Nature Scientific Data with a couple of people, mainly from the biosciences, on the development of metrics for fairness. And we developed fair data reviews. So an online like questionnaire, which by giving answers to questions about a particular data set to arrive at a result of how fair certain data actually is. We apply that, by the way, in one other initiative we took some 7 years ago, I believe, which is the Research Data Journal for the Humanities and Social Sciences, which is a journal in which we invite scholars from the humanities and social sciences. So in particular, also historians. We have a specific section for social and economic history in the journal to contribute papers. And one of the tools we use to review the data that is described in the papers is this FAIR data review. If there are people from Russia that would like to publish an article in this journal, you are certainly welcome. Of course, do read the author instructions well. The articles are relatively short, but we welcome articles. Related to the whole FAIR data movement, also came up the idea that data should be well managed. And this is indeed also an important subject of the new data science. How can data be optimally managed in order to be, in the end, fair. And we see that nowadays many funders, research funders, but also universities, actually all Dutch universities require their staff, when they start a project, to first write a data management plan in which they describe how they plan that they will process the data, how it is going to, where it is going to be stored, whether it will be made available to others, how it will be made available, whether it will get a persistent identifier, and all these kind of questions, how it will be documented, and so on. And I was personally chair of a committee in Europe from an organization called Science Europe that tried to give guidelines and to harmonize those guidelines, because what happened was that every university and every funding organization started to formulate its own data management requirements. The majority was more or less similar, but there were differences in all kinds of details. And we, in my committee, we wrote a practical guide to align all those requirements and to give one harmonized list of what data should comply with. The third essential element is that of linked data and linked open data. And here again, I'm not sure how aware, how familiar the audience of today is with that concept. And I think that probably a couple of you are, and a few will not be, I'm not sure. But the idea dates back to Tim Berners-Lee's idea about the semantic web that dates back again even to the decade before the decade we are focusing on right now. But he formulated a 5-star open data plan where you see here what the steps are, and only the final step is actually that you make your data available as linked open data, that you publish your data as linked open data. Of course, a whole lecture could be given on this subject alone, which we do not have the time for now. Just again, for those who are not familiar with the idea of the semantic web, it was perhaps originally a dream by Tim Berners-Lee. You know, he was the inventor of the World Wide Web as such. And he said, and I like this quote that is in gray on the bottom of the page, "I have a dream for the web in which computers become capable of analyzing all the data of the web, the content, links, and transactions between people and computers. A semantic web which makes this possible has yet to emerge, but when it does, the day-to-day mechanisms of trade, bureaucracy, and our daily lives will be handled by machines talking to machines." Well, partly this dream has come true, but perhaps not in the way that Tim Berners-Lee dreamed about, because huge data corporations, they assemble and collect a lot of data about our daily lives, and also big trades organizations like Amazon and of course Google, and well, you could name all the big ones. And they are linking all those data behind our back, so to say. And by that, in that way, they know a lot about us. But of course, the same ideas have been applied or can be applied to historical data as well. And that is what my last few slides are about. That we could say that in the humanities and in history as well, thousands, tens of thousands of silos, data silos have emerged. Historical databases, linguistic corpora, arts image collections, literary texts collections, archaeological GISs, and you name it. But they are often all separate. And this even works online, fine. How to combine those. So opening up and connecting the silos is one of the challenges of this decade. And actually, linked historical data has been taken as the core of one of the big projects in the humanities, of which the historians form a substantial part, in a project that is called Claria, again, a multi-million euro project, but in the Netherlands, although Claria also has its links to European counterparts, Daria and Clarin, perhaps you have heard of those. But I want to focus here just on one example from one of the so-called work packages in this project, which is on structured data in social and economic history. But you have here a number of links again. If you are interested to see more, you find also in other areas such as in linguistics or on audiovisual media, including oral history, you find links there that link to tools and data that are available from the Claria website. And I will finish with an example from the historical censuses of the Netherlands and how we have been working to integrate those. And you will hear that that was not as easy as we thought it would be. The Dutch censuses, the first one dates back to 1795. We started digitizing them in a collaboration between my institute of the time, that was still the Historical Data Archive, and the Central Bureau of Statistics in the 1990s, the second half of the 1990s. They were scanned. There were, I should say, experiments with optical character recognition, because that was at that time not yet good enough, but you see an example screen there in the middle bottom of the screen. But a lot of it was also just entered manually. In the course of time, thousands of separate data tables were published in different ways, originally also on CD-ROMs, for instance, later websites, and you name it. Everything that was published is archived at DANS, and you see here a reference to the, by way of a persistent identifier, to the data in the DANS archives. But that mass of material existed, thousands and thousands of tables, and of course, over time on different subjects, and how to make that all easy to process for historians who want to analyze that. And for that, we developed originally what we call the CDAR project, Census Data Open and Linked. It started around 2010. At least, I mean, there were more publications, but 2 dissertations were based on this project, came out of this project. You see here the references to them. And in the data journal that I just mentioned is one short article of about 5 pages summarizing it. And I'm here going to summarize again the summary. It will be very brief. I need to be a bit, let us say, give you just an impression of the work that we did in just a couple of slides. But to give you the idea, well, here you see, to begin with, an example of a table from such a census. On the left-hand side, a scanned image representing a table from the original census books. And on the right-hand side, how this data was transcribed. Actually, you see that the source was followed very closely. The structure was maintained as much as possible of the original source. And it was turned into Excel tables at the time. We are talking here about the 1990s, or yeah, the late 1990s again. But if you have thousands of such tables, of course, it's difficult to process them. So how can you link them, and can you turn them into one body of data that you can process easily? this is the workflow that was followed at a glance. And there were 4 main steps. First, there was a pre-processing phase in which the markup of the tables, I will return to the steps, and those will be the last slides. First, there was the markup of the tables to identify what information is where. The second step was to produce raw, as it is called, RDF, which is the data format most used for linked open data from the tables. In the third step, as classification and harmonization had to take place because of shifts in definition over time and shifts in also in how even the most simple variables appear to be over time to be formulated in a variety of ways. Even something simple as the sex of people, men, you would say, yeah, it's either male or female. But again, that can be in a variety, spelled in different ways. And in the original tables, the data from the original images or pages from the census books was taken over. So if there is male in one source and in the next one it is not male, but simply an M, then still you need to harmonize those two and say, yeah, male and M is the same. And this is perhaps the easiest variable that there is. But if we are talking about occupations or regional classifications or housing conditions, or, well, all these other variables are much more, education, they are all much more complicated in structure and needed to be harmonized. And the fourth step was to apply those classification rules. So the classifications were turned into rules in step 3 and then applied to the raw RDF data so that ultimately the so-called release data, the data that is made available, could be produced. Here you see the 4 steps into a bit more detail, and perhaps step 1 was one of the more challenging ones. Here you see different colors indicating different, let us say, classes of information within each table. It is logical that you have, let us say, the headers of columns, the headers of rows. Often there was a hierarchy in those in this information structure, and that was already quite complex to recognize. This was done partly automatically, but partly also it appeared that a manual treatment was additionally necessary. So you can imagine it was labor intensive. The second step, to produce raw RDF from the spreadsheets, well, this is something that actually appeared to be much more simple than we thought. We thought this would be complicated, but it isn't. It is, in essence, fairly easy to turn spreadsheets into raw RDF, and a procedure called tab linker was made. The procedure is available that will do the job quickly. Then step 3 and 4, I take them together because also for want of time, but also because they are closely related. It is about this classification and harmonization, and that again appears to be the difficult part. Here, of course, human knowledge is needed to know about classifications. And we were happy that already for some fields, some areas like historical occupations, classification schemas do exist, such as the HIS code, Historical International Standard Code of Occupations. And we made use, as far as available, from such classifications and turn them into rules that we could then apply to the data in order to get harmonized, what we would say 4-star linked data sets, because then the issue of actually linking it to other sources that are available, that is actually the fifth level, the 5th star. And that fell out. Well, there were some experiments and some examples were done, but that could be developed much further. So you could have a step 5 in which you actually do the linking, and then you And on the website of the CEDAR project, you see a couple of examples of what was done there. I would like to finalize with a couple of lessons learned. That is this linked data approach. One of the advantages is that it offers a systematic methodology of breaking tabular data silos open, and that it enforces a systematic approach to semantic interoperability, which is an expensive word for data harmonization across time and data sets. And that was a very good thing, because many separate, let us say, classifications and so on exist, and they are often applied ad hoc to data, but the linked data approach forces you to do that in a systematic way. And that in itself, I think, has a great advantage. Also that it can then be followed, what exactly has been done. And also, by the way, you are not stuck with one classification schema. If you have an other classification and you say, now I want to look at the data using this other classification, it is also possible. We learned that creating raw RDF from Excel tables is actually a piece of cake, that the pre-processing is very labor intensive, that the harmonization is also complex and requires manual and of course mental power. Also, you would say that perhaps if you have done this, then the data should be fair, but archived linked data is not automatically fair because of access restrictions that may apply, especially if you are dealing also with personal data. It may not be just exposed openly. Moreover, there are still restrictions to interoperability because I cannot say that we were able to solve all the semantic differences in the tables, and especially not in the details, and that therefore still the reusability could still be improved. And looking back over the whole process, that if you want to publish quality linked data from legacy data, it is labor intensive and expensive. And therefore, we originally had the idea in the data archive to make many more data sets available as linked data, but we had to abandon that idea simply because it was too costly, not to make RDF itself, but that doesn't have enough added value. You need to do the harmonization as well in order for the data really to be usable. And that is where my presentation ends. Yeah, I hope that the concepts that I discussed, the example I gave, at least gave a kind of impression what we have been working with and on in the past decade or so. And thank you very much for your attention.
Thank you.
Thank you, Peter. We have very limited time for questions and answers. But anyway, I'd like to ask maybe the most important question. What is your opinion about the share, the proportion of data sets in Western Europe, which could be considered as fair data, completely fair?
Yeah, it is partly easy and partly difficult to answer this question. You know, there is quite a number of data repositories that also comply with certain rules or certain excuse me, certain criteria for quality. And actually those quality criteria that were for a large extent originally formulated in the data seal of approval, later core trust seal. They are very similar to the FAIR principles, but with a couple of exceptions. For instance, the interoperability criterion is usually a difficult one. And also the documentation of the data differs from dataset to dataset within repositories. Although there is some quality demands, not every scholar does it as well and as painstakingly and as accurate as the other. So there's variations. And therefore, that is also why we started with this kind of attempt to star data in terms of fairness. And many data sets have, let us say, a score of, if you have a 5-point scale, perhaps a 3 to 5, 3 to 4, I should say. Only very little has really 5. But then again, we should see that a lot of data is not in repositories at all, is only at the computer of the faculty or the hard drive in the laptop of the individual researcher, and is not known at all. And how big that proportion is, we don't exactly know. There are estimates that say maybe even 80% that is not available in any repository. But I hope this gives a qualified answer.
Yeah, exactly.
There's no easy answer to this.
Either. And I think that I can express the gratitude of all our audience for the possibility to share your presentation. As far as I can see, it is published, the reference is given in this chat, and everybody here could make a copy of your presentation with all necessary references to the author of this presentation. I mean to Dr. Peter Doorn. Are you not against this sharing of your
You know, as professionally, it is my work to make data and information available, and it also includes my own work.
Thank you very much, Peter. And our schedule of the conference dictates to start our parallel sessions. And again, thanks a lot for your brilliant presentation, which gives us the panorama of all these new approaches to making and preservation of historical data. Thank you very much.
Thank you, Peter.
It was a pleasure. Thank you very much for listening to me.
Yeah.
And let us be in touch a bit later, Leonid,
Yes.
perhaps
Yes.
several others. It is easy to have the online chat.
Yes, and just a few words about other current work by Peter Doorn. I mean, his long-term research on ancient Greek geographical history, and there are very interesting results made by GIS possibilities and some new approaches to organization of data. So we hope to attract you, to ask you, to invite you to take part in the in our workshops about GIS and history presentations.
In this way, it is easy to do. So if it is possible, I will gladly do it and could perhaps on another occasion tell something about that.
Thank you very much. Bye-bye, Peter.
Bye-bye.
Bye-bye, Peter. Bye. See you later.
Thanks a lot. Bye.